Hey everybody, so let's go ahead and get started on the Unit 4 exam review part 2. So this is the second part to the review to get you all prepped for your Unit 4 exam. So in this first problem it says, write the equation below in vertex form, identify the line of symmetry, and describe the transformations. So if you'll recall, vertex form is y equals a times x minus h squared plus k. All right, and so we're given this equation here, and we need to identify a, h, and k. Okay, there's several ways of doing this, but what I want to make sure that you guys fully understand is how we can get h and k first. Okay, so to get h and k, you're going to look for that vertex, and you'll see here that we have this vertex here. Okay. Now, on this vertex, our vertex is 1.5, comma 1.75. Okay, and this is your h and your k. So all you're going to do is substitute those in there. Okay, your a is actually going to end up being the a from this equation here. So this equation in standard form, which is y equals x squared minus 3x plus 4. Your a, your b, and your c, well, your a here is just a 1. Okay, so then that means that your equation in this case is going to be y equals 1 times x minus 1.5 squared plus 1.75. And this is the equation in vertex form, given standard form. So we're good with vertex form. To identify the line of symmetry, okay, your line of symmetry is going to go through your vertex here. Okay, so I'm drawing it through here. It's going to go through your vertex. The equation to solve for the line of symmetry, okay, is x equals negative b over 2a. Okay, and you're going to make a quick connection right now, but I want to do this work with you guys. So let's get that negative b. So we're going to say negative, and in parentheses, our b value is negative 3 over 2 times a, which is 1. So this will equal 3 over 2, which is the same as 1.5. And if you see this, it says x equals 1.5, which is actually the x value of our vertex. So your line of symmetry, so we're just going to write this over here. We're going to say line of symmetry is x equals 1.5. And if you know the vertex, then you'll know all the movements. Now the last part there says describe the transformations. Okay, so our transformations, well, that's based off of our parent function. So if we're moving this over our parent function, okay, you simply look at the changes based off of our vertex form, where we would move negative 1.5, we do the opposite. So we would go right 1.5 units and up 1.75 units. And that identifies, we've already identified the symmetry and transformation. So this question had a lot to it. Okay, if you need to go back and pause or replay any of this, go ahead and do that. If you have any questions for me, go ahead and message me through Teams. Okay, let's go ahead and move on. The next question is asking you to do the exact same thing. So you want to write the equation in vertex form. That's y equals a times x minus h squared plus k. So you'll do this part. And if you're having a hard time seeing the equation here in standard form, it is y equals 1 over 4 x squared minus 2x plus 2. And I'll be checking your work as you are working through this problem. Okay, go ahead and continue when you're done. So for this problem, it says, what is the equation that contains the points -1, 0, 0, -6, and 1, -8? And so what we did here is we had to use Desmos. So when we go through this, you always want to make sure that you label your points x and y, x and y, x and y. And in Desmos, we had to use the quadratic regression equation. And that's in here. That is the y1 squiggle ax1 squared plus bx1 plus c. And then you have to input your table. Okay, again, to input your table, you're going to push add element. You'll put table, and then be very, very careful, guys, that you switch these values to x1 and y1. They will always pre-populate as x2, y2. So you want to switch those to x1, y1, and then you put in your points. Now to get the equation, you need to pull the parameters. So you'll identify your A, which is -10, your B, which is -4, and your C, which is 6. So when we plug in with our equation, which is y equals ax squared plus bx plus c, and we substitute in respectively here, here, and here, you'll get that y equals -10x squared minus 4x plus 6. And there you go. And so on this problem, guys, you're going to go ahead and do the exact same steps that I just did on the previous problem. Okay, so make sure that you go into Desmos and make sure that you follow all the steps that I did on the previous problem. Let's move on. And so this last problem here, guys, is actually the same routine that you're going to do for the previous problems. There's only one step difference. We have to get the line of best fit. So we'll identify our parameters. And so we'll be able to say that this is y equals our A value. We're going to say is 0.24. We'll say B is 0.76. And C equals 4.03. So when we substitute into our equation, we'll say 0.24 x squared plus 0.76 x plus 4.03. And this is our line of best fit. Okay. Now, given this, the next question is asking us, is the quadratic regression a good fit for the data? We would say, okay, well, actually, before we can say anything, we need to identify our r squared value. And so we would say yes, because r squared is equal to 1, which is a perfect line of best fit. Okay, so you need to do both. You need to identify the line of best fit given the parameters, and you need to describe whether or not this is a good line of best fit based off your r squared value. Remember, anything r squared of 0.8 or better is a good line of best fit. So then on the next problem, you're going to put these data points in here into your Desmos using the same quadratic regression formula. So just as a reminder, that is y1 squiggle ax1 squared plus bx1 plus c. You need to identify your A, your B, and C, and go over that r squared value. What does it equal, and what does it mean? Okay, if you guys have any questions over this review, please be sure to send me a message in Teams, and I'll be hopping around to the groups and supporting you guys in class. Have a good day, and we'll talk to you later.